is only take a second. I'll just project it right on there. And you'll look at this thing and you'll see a lot of you already made that graph. But you just want to see how is this thing looking when I put this on there. So if you didn't bring your graphing calculator today, it's a piece of cake. You go in here and we're like, I want to verify this with my tool. Can I hit the lights? Alright, clear. Let me get that straight. And I'll pull this back so everyone can see that. Everyone see this thing? So I got a y equals. First thing I got to make sure none of these plots are highlighted. That's for stats. So I just hit enter and it unhighlights that. Right? Zoom 6 gives you a nice standard window, everyone, if you just want to hit Zoom 6. But I'm going to type in, I got to start with the parentheses, right? Parentheses, 2x plus 12, close parentheses, division. Where can I get ABS? Second 0. So I'm going to hit second 0 and it gives me this ABS for absolute value. Then I just type the x plus 1. That's plus 6. Now if you want a standard window, you can just hit Zoom 6. Zoom 6 is standard window and I'll hit 1. Let's just see. Let's see, was anything missing in there? Oh, that extra what? Good call, there had an extra parentheses in there. So Zoom 6 this thing, let's see how it looks. Awesome, the only thing is, what's it doing there at the middle? It did a what? Connection, does everyone see that? Makes it look weird, like it's connected. Well, a lot of times you can go into like this mode, and when you see where it says like function, like if you even, let's see if we do like connected, if I just do like, what if I did dots? Let's just see how it looks I did dots. Isn't that funny? So it's funny, sometimes like, this thing can be a little deceiving, and I didn't want to trick you. Like you're like, we know that's the graph. But I made this look better by just going in the mode, and going here, I have an old TI-84 and I put it in dot mode rather than connected mode. Right? It's funny, you go, but it isn't connected, is it? This function's not continuous at x equal to -6. So that's just a bad calculator when it does that. That's wrong, isn't it? It is not doing that. So I just went to mode and changed connected to dot just to see, alright, yeah, that's what's going on there. And there's really open circles at either end, isn't there? Hey, thanks, Trey. I just wanted you to see that. Cool. Hey, so the remaining part to today is, can we do a trig graph? Is trig gonna be tough? Did everyone get a trig sheet? Throughout this week, we might be discussing some trig, because sometimes we gotta go back and remember that stuff. So, if any of that stuff in that trig sheet seems a little foggy, right? And you're like, I need to review that, then let's talk about that in class. So, didn't I do this? I did the sine curve, right? I did the sine curve. Okay, well then, let me draw it again. What's sine of x look like? I'm going to give you a limit problem, and I'm going to give you some kind of trig function. I'm not going to do sine. What's the sine curve do right here? Yeah, pi over 2, and then a pi, and then 3 pi over 2, and then a 2 pi, right? So doesn't it go like this? Woo! Then down here it goes like this. How high did it get? 1. How low does it get? -1. What's it do on this side? Yeah, it just comes down here at negative pi over 2. What's it get to over here? Negative pi, on agree? That's far enough. I'm not asking about that. No, I want you to find this. Cardinal limit. X approaches, let's see. Oh, I got it. Pi. Now this function. Ooh, no, don't lay it. This is not intimidating at us. We can do this. Cosecant of x. How do you make the cosecant of x graph? It's a piece of cake if you can make that graph. Because that's his reciprocal value, right?
Yeah.
Sine of x is equal to, right? Or so I should say it this way, cosecant of x is equal to 1 over sine of x. They're called reciprocal values. So cosecant of x is 1 over sine of x. Well, what's its graph look like? I go off this thing, what do I make?
It's just gonna be flipped.
Yeah, you make these little hills. They're like these little parabolas like this. Shh, it's that one right there. And when here in yellow chalk is the graph of cosecant of x. What's doing on this problem? But this graph does have asymptotes. Can you all tell where the asymptotes are?
Pi 2.
No, you're good. Now you know why I asked you what's going on in pi. Alright, so this is just going to go like that, wherever there's an asymptote right between these. Can you see it? But now I made the graph. What's the limit as x approaches pi? From both sides. From both sides.
Doesn't exist.
Very good. But I think I should give you two of these, so here's my next one. Can you find the limit as x approaches pi from the left side of cosecant of x? Let's do it. As you approach pi from the left side, where's it going? Infinity. Nice. Good job. So I got another one. All we need is the graph. Who's his buddy though?
Cosine.
Yeah, cosine of x. 1 over secant of x is cosine, right? It's cosine x, right? Well, I just need to make the cosine graph and make those little hills. Well, what's a cosine graph do? Alright, let's see. 2 pi. 3 over 2 pi. What's this graph? And by the way, I'll put these on that trick sheet so you can go back and review this stuff. What's this graph do? This graph starts at 1 in the air, it ends at 1 in the air at the 2 pi, and it's just kind of halfway at pi, it's way down here. So it went from here, halfway it got down to a -1, then it got back up to a what? 1. And it's smooth, it just goes, yeah, 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 yeah. Now where's the hills though for that secant of x graph? Where's the hill? I can see one here, where's the next one? Can anyone see it? Do this big. There it is. And when that's y equal to secant of x. I'm going to draw this graph. What's it do over here? Let me keep going. What's it do over here? Pi over 2. What's it get to down here? Negative pi. Okay, to negative 3 pi over 2. And where is this function at negative 2 pi? Let's back up. Now, when do you see the other hill? So where are the asymptotes? Oh, I missed this one. What's going on right here? Whoa, I don't want to go close. This thing goes right there. A tangent between them. There you go. So, everyone, what's the limit? As x approaches pi over 2, oh, and let me add something to this if you don't mind. How about from the right side? As you approach, look at the yellow chalk, get on this curve. As you approach pi over 2 from the right, where is it going? Good job. So isn't this cool, even though this stuff, we do this actually in 2.6, you can do it now. You just gotta look at things graphically. Isn't that awesome? So see, there's nothing that can stump you. I'm telling you, you go, oh, well what if that absolute value thing drove me nuts, right? Well, then you'll use your what? Calculator. Just maybe put it in that dot mode. It might look a little better. But is that okay, you think, you simplify those absolute value expressions? Hey, on Thursday when we're reviewing, feel free to holler at me and go, hey, can we do another one of those? And I'll just make something up like x plus 8 over absolute value of x plus 8. And you will see what we get. And it'll limit as x approaches. If I do one side, you might get a number. I think if we do 2 sides, it's going to what? It's going to do one of these, isn't it? True? So I'll probably in the test just do one side. Hey, so, couple things. Would you just try that real quick? This right here. From the left. I'm just curious. Now, there are numerous ways to do this problem. Do you know how to break this into 2 parts? Sure. Which side do we need, the left or the right? So what's going on the left side? What is this expression equal to? On the left side, what is it? X plus 5, what's another way to write that? Ooh, big, very good. You put the negative there, and then I say if x is less than what? If x plus 5 is less than or equal to a what? 0. So when I now see my error, I meant to say the limit as x approaches a what? a negative 5 on the left. Alright, so if x is less than a what? And can I put the equal symbol?
But wouldn't it be
Can I put that equal symbol?
fine if you put if it's equal to -5?
Yeah, equal -5, right? Yeah, I love it, that's the better way to write it. Hey, can I put that equals? No, I can't, can I? Function won't exist there, true? So I'm just do a less, x plus 5 less than 0. Left side, right, because we're doing left side? Which means, as you said a better way to write that, and I think it was a great point, you said better write this, x is less than -5. Cool. So this is what I have. Does anything cancel?
Yes.
Ah, then what's the answer? What do you think?
Negative.
If we didn't make the graph, then we should get -1. Now look at your graphs, and you'll probably see that, right? And is it really going there? Alright, let's look. Pull this thing out, and just look at this thing. What we got typed in here? Is this really going towards that? I go to y equals, alright, clear UL. What was the top? I went second 0 for abs. It was x plus 5, what was in the bottom?
Regular x plus 5.
Just regular, parentheses. X plus 5. Ah, I did the connected. I'm gonna go to mode and make it what? It's still on dot, huh? It's still doing that. Well, we're gonna outsmart this calculator, right? I bet you I know what I can do. If I just did what? Let me see if sequence. Maybe sequence looks better with a bunch of dots. Can everyone see those little dots in there? I actually show little dots in there. But yeah, that graph, I could still see it work. That was at -1, but it did make that little piece together there. Cool. Hey, here's the last problem I wanted to do with you today. Absolutely, feel free to do this. I always like to tie in what we're doing today into something we're gonna do tomorrow. What's the only way we were focused on all day today on limits? What technique? Finding limits graphically, right? And I bet you're an expert. Just make the graph, look to see what's going on. If both sides meet from the left and the right side, then the two-sided limit exists, right? Well, I put up this problem earlier. Is this right? I'm hoping. Can I have this?
Yeah.
And I wrote 3, which side did I do?
Probably from the left. Yeah, from the left.
Okay, so half hour ago I had this problem. This is how I went to end class today. Limit x approaches 3 from the left side. We did this which way? How did we find this answer? We made a graph. It works! But is that the only way to find limit answers in mathematics? And you go, no. There's another technique. It's tomorrow. I just thought I'd give you a tie and then we'll break and get out of here. There's another way. We know graphically.
Isn't there something degree? Like the power?
Ooh, I love it.
Basically, you just sub in numbers.
I love it. You all are great because you just start subbing in numbers. We just want to know what's going on as you get really, really close to what number? 3. From which side? From the left. So, and can you just help me out? Brainstorm right now. We're just going to plug it in to see this answer. All right, we'll match it to the answer we got before. I am not making a graph. I'm going to find this limit numerically. So what's the number really close to 3 from the left side of 3? So you got to think of a number line, everyone. Here's the number 3, but over here, really, really close. 2.1. 2.9. Go better. Go better. I like that. I like that. I like what you just said. How about, let's plug it in here, 2.9999 into my calculator. All right, so what is on the calculator? 2 over 2 point, he said 9999. You can put another 9 if you want. And just, I want to see this number. Is it really, really huge? Or is it really, really huge and negative? And we should get an idea of what's going on with this actual graph. What comes out on this calculator?
Got negative 20,000.
That's huge and it's negative. Where do you think this thing's going?
Negative.
What's it heading towards? Just from that one little plug, you and I have a sense of what's going on here. That's a very, very, very large negative number. It looks like this is heading to what? Is that what we got before? So that's called finding limits numerically. Absolutely you can do that. Absolutely, that's full credit for justification on a test. You know, I applaud you. I'm like, that's good thinking. Students do that all the time, so we always think that way too, right? Awesome. Hey, great job today, everyone. We'll do that tomorrow, but that's a great way to think. So there's 3 ways to find limits. We haven't done the algebraic technique. We'll spend 1 class for that. That's 2.3. Have a great day.
Great night.